am going to go over all the basics again. And we're going to start with what is an equation. Now, how do you know whether you're dealing with an expression or an equation? Now, again, we have covered expressions already. So if that is something you're confused on, go back and watch it. An expression is really just a combination of variables. Hello, let me write, please. Oh my gosh, give me a second. It is a combination of variables, exponents, and coefficients. That really is what an expression is. So, okay, let me actually start from the beginning. Let's talk about what terms are. And maybe I should do this again. So let's talk about a term. When we talk about a term is a combination of variables, exponents, and coefficients. That is what a term is. Okay, so let's put it down a variable, let's put down an exponent and a coefficient. This is a term. Okay, when we have an expression, let me change color. Give me a second, I have to stop sharing. Okay. When we're talking about an expression really is just a combination of terms, or we can say rather a collection of terms. So when you have a term, that is a combination of variables, exponents, variables, exponents, coefficients. So when you put those together, you get a term. When you put a bunch of terms together, you get an expression. Now, really important to know that in an expression, terms are separated. Let me move this way. Terms are separated by plus signs or by minus signs. So let's get some terms, right? A coefficient is 8y cubed. Let's go 7x, and let's go 12x cubed, and let's go 19y cubed. Okay. Now, if I put these all together, what happens is I've now created an expression because I've collected all of these terms together. If I had to ask you guys how many terms are in the expression, well, what you would do is you would count the pluses and minuses, and then you would count how many groups the pluses and minuses have created. So there's 1, 2, 3, 4. So this is an expression with 4 terms. Remember, an expression is a collection of terms. So this specific expression has 4 terms. You can have an expression that has 2 terms, that has a million terms. As long as they are terms that you've put together, they're separated by pluses and minuses, we call it an expression. Now, there's a lot of expression rules which I'm not going to go over. But once we understand expressions, we then have what we call an equation. What's the difference between an expression and an equation? Well, When you have an equation has a left-hand side and a right-hand side, and those sides are separated by an equals to sign. So when you have an expression, there is no left-hand side or right-hand side. It's just a collection of terms. But when you have an equation, there's an equals to sign in the middle, which creates a left-hand side and a right-hand side. Now, more specifically, an equation is a statement. It's a statement that two expressions are equal to each other. Let's take an example. Let's look at two different kinds of expressions. Let's say we have 2x plus 7. And let's say we have x squared minus 3x. Those are two different expressions. I have collected terms. I want to ask you guys, in this first expression in green, how many terms are in that expression? Guys? Two. Mahanya, you're 100% correct. There are two terms in that first expression. And there are also two terms in my second expression. So there are two different expressions, and each expression has two terms. Now, to create an equation is a statement that two expressions are equal. So what if I took both those expressions and I made a statement that they are equal? Well, the minute that I do that, I have created what we call an equation. So that is really important to know. An equation really is just two expressions that are equal to each other. That's why we have a left-hand side and a right-hand side. Expression number 1 is on the left-hand side, expression number 2 is on the right-hand side. Another bit of a hint that you could use to differentiate between your expressions and your equations, especially in tests. I remember when I was kind of in grade 8, I didn't know when to apply expression rules and when to apply equation rules. And so a little bit of a hint there is, when you're doing expressions in an exam, your instruction is simplify. Okay? The most that you can do with an expression is you can simplify it. But when you're dealing with an equation, the instruction there is solve. I used to get really confused, right? Because in class, you know you're doing expressions, so you know to apply exponent rules, you know to apply your expression rules. When you're doing equations in class, you know you're doing equations, so you know to apply equation rules. But in a test, they don't tell you whether it's an equation or an expression. They just give you an instruction, solve, simplify. And I used to be confused. What is it? What rules do I apply? When your instruction is solve, that is an equation. You apply equation rules. When your instruction is simplify, that is an expression. You apply expression rules. So that's just some background knowledge on expressions and equations. Can I please see some reactions? How are we all feeling about the background knowledge? Okay, lots of thumbs ups, but I don't trust your thumbs ups anymore. So we'll see when we get to the questions. We're looking at the golden rules of solving equations. Okay, really important that you guys know these three basic things. the first thing you have to know about an equation is what is your objective. And so the objective of solving an equation is to get your variable by itself on one side of the equation. So when you're given an equation and you're asking yourself, well, what do I do? I don't know what to do. Well, what you're going to do is you're going to do stuff that's going to help you to get the variable by itself. That's why we do everything that we do in an equation. We take steps to get the variable by itself. Now, getting the variable by itself is easier said than done. But let me show you guys something really quickly. So let's say I have x plus 7 equals 10. Without really thinking about it, what do you guys think x is equals to? 3, right? We knew that because we're basically saying, okay, something plus 7 is 10. And so I know, okay, 3 plus 7 is 10. So my answer here is that x is equals to 3. And this is my answer to this equation. And what I want you guys to see is that we got x alone. X is now alone on my one side of my equation. And so that's really what we're trying to do. That's how you know you're completed. When you have your variable on its own on the one side of the equation, you know you're done. Now, how do we actually do that? Showing our steps. Well, to solve an equation, meaning to get the variable by itself, you need to use inverse operations. What do I mean by that? Well, let's take this equation that I had. It was x plus 7 equals 10. Remember, my goal is to get x alone, which means this positive 7 is irritating me. I don't want it to be on the side with x. I want to remove it. And the way that I remove it is by using inverse operations. To cancel out a positive 7, I'm going to subtract 7. So that's how you get your variable alone. You use inverse operations to cancel out anything that's on the same side as your variable. But once you've used inverse operations, what you do to one side of the equation, you must do to both sides. So if I have minus 7 on one side, I must minus 7 on the other side. And you'll see that what you get now is x plus 7 minus 7 is just x. And then we have 10 minus 7, which is 3. And so we got the answer here, but this was what we call solving by inspection. That's solving just by looking. You can only really do that with really easy equations. If I were to ask you to show steps, this is the steps that you would show. Okay? Yeah, and so that is it. Was that a hand or a message that I heard?
Ma'am,
yes.
Ma'am, so if you don't do the first step and then you just say 10 minus 6, they mark it wrong.
If you don't do which first step? The one with the plus 7 and minus 7?
Ma'am, if you only say 10 minus 7 and you don't do the x is equals to 7 minus 7 equals 10 minus 7.
So this step here.
Yes, ma'am.
Sorry, I'm a little confused. Which are you asking me? Okay. This is kind of like the basics, right? So when you're first starting out, I'm always going to show you all the steps. But in a test, you don't have to show every single step. Now, that's a very slippery slope though, because yes, you don't have to show every single step, but there are certain steps which are really important that you can't skip. For this though, there is a step, there is a shortcut that we use, Warine, and that's when we kind of just move it to the other side. So you don't have to show the +7 -7 and the 10 -7. You can just use your shortcut, which I'll show you a little bit later. So no, if you don't show +7 -7, they don't necessarily mark you wrong. Why I am showing you this is I'm showing you the logic behind that shortcut. We tend to always use the shortcut because it is shorter, but I just want to show you that that's a shortcut. We're not straying from our golden rules of using inverse operations, and what you do on the one side, you do on the other side. When you move something from one side of the equation to the other, that's just a shortcut of using inverse operations and doing it on both sides. And so let's talk about that. The shortcut to this, guys, what does that look like? Now, when we're solving equations, there is a shortcut to using the inverse of addition and subtraction. The shortcut only works to reverse addition and subtraction. Please do not tell me you're going to take a coefficient to the other side. Remember, a coefficient is multiplication. The coefficient is the number in front of your variable. That is multiplication. So you will never see me saying take your 2 to the other side. That will not work. You can only do it with addition and subtraction. And so we have a shortcut to showing this step. And the shortcut, we call it transposing. We say we transpose. And what happens is, instead of going +7 -7 and then -7 on the other side, what we do is we say, okay, I have a term here which is just +7. It is addition. And so the shortcut of getting that x alone is to just say, okay, well, because it's addition, I can take that +7 to the other side of my equation. But when you take something to the other side of your equation, it changes sign. So it now becomes 10, and instead of +7, it is -7. And what you'll see is you kind of get the exact same thing. Because here we had x +7 -7, which really is the same thing as just x equals to 10 -7. So this is the long way that follows the proper principles. And this is the shortcut of the long way. But even though it is a shortcut, it's still following the principles of inverse operations and doing it on both sides. So this is the shortcut to doing this, Warine. So if you were showing your working out and it looked like this would have been marked 100%, just like this would have been marked 100%. Does that answer your question?
Yes, ma'am. Thank you, ma'am.
Pleasure. Okay. So that's that. Let's move on now to actually answering some questions. Was that a hand? Yes, I had a hand.
Ma'am, at the beginning, you don't have to. Do you have to like? Okay, let's say you want to do the shortcut. Ma'am, you don't have to necessarily say x +7 -7 is equal to 10 -7. You could just say x +7 is equal to 10, and then change that because we said want a variable to itself, right? We're gonna say x is equals to 10 -7. But then my one thing that I'm confused about is like at the beginning, why do you have x +7 -7? Like where did we get the second 7?
Okay, so I think you joined in late, so you didn't hear when I was explaining that first. But when we're solving equations, there is 3 things we should know. First, we want to get our variable alone. You said that, you know that. The next thing, to get your variable alone, you must use inverse operations. And so what I said was, okay, to get my x alone, this positive 7 is irritating me. It's bothering me. It's on the side of my x. I don't want it to be on the side of x. And so to solve an equation, you use inverse operations. And so in order for me to cancel out that positive 7, I subtracted 7. But because I subtracted 7 on the one side, I had to subtract 7 on the other side as well. And so that is how we kind of got x plus 7